Hi everyone, welcome to the new episode of the Prime U series of interviews with top business and technology experts. Today I'm delighted to welcome to the show Ben Ofiri, who is co-founder and CEO of Komodor, a startup company that built a tool and a platform for Kubernetes troubleshooting. Ben, I know that you spent over a decade in IT technology. You've been working at Google for over 6 years. So if you could elaborate a little bit more about what you were doing at Google and if you actually got the chance to work with Kubernetes there.
Yeah, definitely. So first of all, as you mentioned, I started as a software developer at Google, and I've been working for several teams there. And later on, I transitioned to a product management role, which is a super interesting story if you want to hear why I did this transition and what were the outcomes. But as a software developer, you don't have any other choice but getting your hands dirty on Kubernetes. So internally, Kubernetes in Google, it has a different name, it's Borg, and this is basically the only solution you can have to manage microservices within Google. So I didn't have any choice besides being an expert in basically Kubernetes, deployments in Kubernetes, and obviously troubleshooting is Kubernetes as a software developer and later on as a product manager in Google. So I definitely had a lot of experience working with Kubernetes back then. After I left Google, and I started to do some research about what other companies are using, first of all, to manage microservices, but also for monitoring logs, analytics, etc. I was quite surprised or quite a shock that Kubernetes is not the standard in the industry. So it was like 2 years ago. And I assumed that, Kubernetes is great. Google uses it, Netflix uses it. I assume that all the companies are using it already. And for me, it was a shock to discover that, some companies still using VMware's, EC2 machines, bare metal. So I'm super glad to see that today it seems that Kubernetes is catching up and de facto becomes the standard for cloud operations and managing microservices.
That's a very interesting point you have just made about the other technologies available, right? That probably play similar role for the companies to Kubernetes. So if you could tell me from your perspective, as you have, I believe, in-depth knowledge of Kubernetes, of that technology, how different is that and what kind of problems it helps to solve to companies?
Sure. So I think from the technological perspective, Kubernetes provides a layer of abstraction that on one hand can be super powerful. In fact, in 1 or 2 days of work, you can implement and enforce an infrastructure and architecture that probably like 10 years ago would require 20 people in the IT department. And you can do it from your garage just by writing code, which is pretty amazing, right? So from the technological perspective, I think that the layers of abstraction and the right amount of configurability versus the abstraction is something that Kubernetes is doing very well. And on the other hand, the nice thing about it is that, as you probably know, it started as an internal project for Google, etc. But since it's an open source project, and there are so many contributors from different companies and private people, etc. So it almost becomes like this ecosystem that is in a way self-healing, right? So every time something is missing, a feature request, there is a bug, there is a capability that is missing, just in a few days or weeks, you can see that it's already being covered, tested, and working in production for different enterprises and different environments, which give you the confidence as a developer to adapt this technology, and then basically it feeds itself, right? Because as more and more people adapting Kubernetes, and as it becomes the standard, more people are contributing to that. So things are becoming much more stable, and then you can have more companies adapting it in the first place. So we definitely see this loop of how Kubernetes become much more prominent and much more the default choice for more and more organizations.
Well, I'm actually a great proponent of open source technology, and I believe this is where the innovation is, as there's so many contributions, right, happening every day and every minute that actually make this product and that technology evolve really fast comparing to proprietary ones.
Just to add, it's so prominent right now, like Kubernetes and its effect, you can actually notice that there are several very popular projects that are already built on top of Kubernetes, which 5 years ago, it will be, a dream, right? So you have Prometheus, you have Argo CD, you have so many different projects that are built on top of Kubernetes that are becoming much more popular for monitoring, for deployments. So it's great to see that, it's not only Kubernetes, but it's an entire ecosystem of tools and companies that are relying on Kubernetes as basically the heart of this ecosystem, or if you will, maybe the operating system of this ecosystem. And you can see more and more companies actually relying on that as the underlying infrastructure.
Yeah, another point that I'm really interested in is about what was it about Kubernetes that made you think that you want to leave Google and start your own company that would help developers, software people to understand better Kubernetes applications?
Sure. So it was not, one scenario that I can, reconstruct to tell you that in this moment I decided that I want to invest, the next 5 to 10 years of my life building Komodor. But it was actually an aggregated experience I had firsthand as a developer, and later on, after a deep research, my partner and I did. And what struck us the most is that once companies adopting Kubernetes, and obviously it becomes more and more common for companies to do so. So on one hand, it gives them, a lot of power out of the box and a lot of things that they can do. But the amazing thing is that, when something goes off in this very complex system, right, like Kubernetes, you would assume that you will have some tools or some processes in order to handle those kind of things as well, because nothing is perfect, right? So for example, you can imagine a hand watch that you might be wearing. So it works great in 99.9% of the time. You always know the hour, right? The time. But when it goes off, you don't know what to do with it, right? You need to go to some professional to help you fix it because it's very complex under the hood because of all of the abstraction layers that you enjoy in 99% of the time. So what struck me the most is that Kubernetes is much more complex than a hand watch. Believe me, it's like 10,000 times more complex. And when something goes off, and unfortunately, always something goes off, the developers are basically clueless. So, in 99% of their time, they're writing code, developing new features, they're living the dream, right? And then all of a sudden they get an alert that some pod is being restarted. They're not even sure what a pod in Kubernetes is, and definitely not why it's being restarted. And then for some reason, the organization just expect them to be an expert in troubleshooting Kubernetes. So they're expected, to check the logs, check the pod, check the nodes, check the memory issues, check if something was changed in the configuration or in the deployment, and explore all of those things, even though no one really equipped them with the tools, expertise, or knowledge to do it efficiently. And I felt it firsthand as a developer, right? But I thought for myself, like, what do I know? I'm only like one developer in Google. So we started actually to do a research and to ask, developers and on-call developers, like, hey, like, you probably had an alert in the last couple of hours or days, right? What did you do in order to solve it? Like, how many tools you needed to use? How many people were involved? And what we learned is that it's like a black magic. Like, no one wants to talk about this non-sexy part of troubleshooting, but developers really don't have the right tools and expertise to do that. So they're either escalating team members to help them. They might be escalating to other departments like the SRE or DevOps to do that because they feel that they don't have the tools to do it efficiently. Or they might try to do it by themselves, but it's getting a lot of frustration on their hand because they're not really good at it. And they're doing it instead of writing code and developing new features, which is why, at least from their perspective, is the reason the organization hired them. So it actually creates a lot of frustration and frictions from the developers as well. So once we learned that, and once we felt that, and once we knew that it's a real problem, in our opinion, in our thesis, is it's only going to get worse since more companies are adopting Kubernetes and managed cloud services, etc. And it's definitely not going to be resolved by itself. So at this point, we said to ourselves, like, there must be a massive change. There must be huge shift in how developers and how modern DevOps are troubleshooting Kubernetes, understanding Kubernetes, and operating with Kubernetes. And we want basically to be, at least one of the factors that leading this change. And I think that at this point, we decided this is a good, usage of like 5 to 10 years of our time, try to be part of this revolution.
Yeah, that's a great story, and the story of the insider, the person who actually understands the pain points of people working with a specific technology. What I'm interested in right now is about the way, how do you onboard new users, right? How do you actually generate demand for your solution?
Sure. So it's a great question. And since we're a relatively younger organization as ourselves, we're still learning as time goes by, because we meet so many different customers with so many different profiles. So it's actually intriguing, like, to learn how different organizations are working, and how to find the right pain points and the right persona within the organization. What I can tell you that works the best for us is something that is it's like a trick that we learned along the way. And basically what we learned is that for most organizations who just starting to adopt Kubernetes or already using Kubernetes, usually what happens is that, as I mentioned earlier, there is an expectation from the developers to operate and troubleshoot, but they don't really know how to do it efficiently. So usually they're escalating very quickly to the DevOps and SRE, right? Now, those people like the DevOps and SRE, they know how to do those things. They're probably the team that chose to use Kubernetes, that implemented Kubernetes, and all of the other surrounding tools. So they definitely know how to troubleshoot complex cases, right? But it's a really bad usage of their time, because you definitely don't want the 600K USD per year the DevOps people to troubleshoot the entire day, or to firefight the entire day, right? You want them to develop the infrastructure, you want them to develop the CI/CD tools, you want them to make a more reliable platform, etc. You definitely don't want them to get just tickets of alerts and ask them to troubleshoot the day-to-day things, right? So usually what happens is that those people actively looking for tools that will empower the developers to understand how to do those things by themselves, so they won't be the bottleneck of the organization. And when this happens, Kubernetes is almost like a glove, because they're actually looking for a tool that will digest Kubernetes and will serve it in a digested way for the developers, so they can share some of the load of troubleshooting and doing the reliability in Kubernetes, instead of being like the bottleneck as the DevOps and the SRE. So usually this is like what happens for us. Like, we get an inbound query from some DevOps or SRE that is desperately looking to empower the developers, to provide them tools or visibility or even like troubleshooting tools for Kubernetes. And then it's exactly what we can do. So it's usually a very good fit to help those kind of customers.
Well, Ben, you're talking a lot about 3 pillars of Kubernetes troubleshooting. What I am specifically aware of is 3 pillars of Kubernetes observability, which are logs, metrics, and traces that when they are combined together, they can actually provide sufficient insights to monitor software at any scale. So, but I believe you're talking about different pillars. If you could please elaborate a little bit more on that, and how do you specifically help to tackle the issues connected with each and every pillar?
Sure. So first of all, when we talk about the 3 pillars of troubleshooting, is basically the way we see the world. So obviously we don't try to claim that, this is the objective truth, but it's more of like how we interpret what troubleshooting is in modern systems. And for us, troubleshooting consists of 3 different pillars, and it's understanding, managing, and then preventing. Okay, and I will touch each one of those pillars, because each one of them is different from the other, but together we think they're combined together. They're basically what troubleshooting should be, or what troubleshooting is in modern systems. So first of all, the understand part, right? So you get an alert, you get a customer complaining, you get some pod that is, doing some troubles in production. Something is off, right? The first thing you need to do as an on-call developer, as like the on-call DevOps in the team, is really to understand what's going on, okay? And this is a very hard task, because what's going on in a system that is composed of, 5,000 different microservices with 20,000 different pods that are constantly changing every minute is not something easy, right? So if you ask yourself, what the heck changed in the last couple of minutes? the answer is not that trivial. So basically, to understand really what's going on, you need a lot of context regarding what are the ongoing services, what are the relations between the different services and pods, what is the status of each one of those components, when it was the last time they were changed, if they were changed, was it a configuration change, a code change, an infrastructure change. So basically, you need to gather all of this information and then use different logic or intuition or experience on top of this information to really get the right sense of, okay, now I understand what happened, right? So this is like one huge bucket. And by the way, like research shows that 80% of the time, given an issue, given an incident in modern system, goes to the understanding part. So this is definitely not like, a 3-second thing and that's it. Now, right after we understand better what happened, so basically maybe you have like a list of defected pods, you have a list of some changes that look suspicious, you have maybe another alert you find that might shed some more light on the root cause. Now basically you need to manage this incident, right? Like you need to take action. It won't resolve from itself, right? So in the manage part, basically I like to think about it in two different ways. One of them is the collaboration and communication you need to do with other team members. Maybe you need to update, the team that you are working on it. Maybe you need to collaborate with other team members to solve the issue. So there is a lot of communication and collaboration phase. The second thing in the manage is the action you need to take in order to really resolve the issue. So let's assume that, we collaborated, we chatted for a bit, we did a virtual war room. Now we think we found the root cause. Now, what do we do? Like probably a revert, a rollback. Maybe we write new code and fix it. Maybe we change something in the configuration. Maybe we blame other team or a third party, right? It's also a possibility, but there is some action you need to take, right? So this is what we call like the manage pillar. And lastly, you took an action and everything back to normal, right? You are not done because now you need to prevent similar issues to reoccur in your system. Otherwise, tomorrow it will happen again, right? And maybe you or someone else will receive the same alert and will do everything from scratch. So if you really want to troubleshoot, you also need to think about preventive, right? What can I do now so this issue or similar issues won't reoccur in the system? And for us, like in Komodor, what we think is that if we really want to own the troubleshooting for Kubernetes, we need to provide significant value in all of the three different pillars, because if you do only one of them without the two other, or only two without the third, you're missing the bigger picture. You're missing really how to build an efficient and powerful troubleshooting process within the organizations. So obviously, we're a small startup. I can't say that we're acing in all of the three pillars, and after like 30 minutes of installation, it's resolved. But we do have a lot of value we provide in the understanding part, in the managing part, and then in the preventive part.
Ben, that would be particularly interesting right now to hear a case study or an example of how you helped or your tool helped your existing client to solve a certain problem, and what were the steps that were taken to figure out what happened, right? And how they were managing the problem and maybe how they were preventing other issues from appearing.
Sure. So maybe like I will give, a lightweight example of, how we actually solve or help solving issues in Kubernetes, and then we can, relate to the pillars themselves. So one concrete example we had just a few days ago or a few weeks ago with one of our customers is that we did the onboarding, they started to use Komodor, and then they had like the real issue in their system. So an alert from Datadog and then from PagerDuty hit and says that there is a high latency in one of the services. Now, before Komodor, what would happen is probably this alert will be routed to Slack, to some production channel in Slack. And then, the whole mess will begin, right? Like the on-call developer will probably start to ask, hey, who touched production? Who did something recently? Hey, Joe, can you check the logs? Hey, Bob, can you check if something happened in Kubernetes? And, this is the chaotic process that will probably happen to this organization without Komodor. Now, what happened is that they were using Komodor. In fact, they were doing a trial with us during this time. And the on-call developer noticed that from the alert, it's being routed to Slack, we have some checks that we perform once we have an alert to try to shed some light, like to try to provide a first aid of context to the origin or to a possible root causes given an alert. So basically our Slack bot found a few interesting things that happen in the system right before the alert on the same service that basically had the symptoms. So our bot found that on the same service, there was a few deploys right before the alert. So this is obviously an interesting piece of information, right? Like, there was an alert and the service would just got deployed. It's probably a good place to start looking on this specific service. So basically the user saw this over Slack, he clicked on the Slack bot, he was being routed into Komodor. And then after 2 seconds of observation, he noticed the alert, he noticed the deploy that happened right before that. And more than that, once he clicked on the deploy, Komodor basically showed the on-call developer exactly what changed as part of this deploy. And guess what? He saw that there were some code changes in GitHub, which felt a bit irrelevant to the high latency the service suffered. But he also saw that someone changed the Kubernetes manifest and actually decreased the number of replicas for this specific service from 50 replicas to 5. So basically in a single click, he was able to see that the service was not only deployed right before the alert, but actually the deploy also contained some change in Kubernetes that caused the service to have only 5 replicas available instead of 50. So at this point, they realized that this is probably the root cause, right? This specific deploy is probably the root cause for the high latency. And in a single click via our system, they were able to revert the faulty deploy and bring back the state back to normal as it was 5 minutes before the alert. So basically in 3 or 4 clicks from the alert to the inspection, to finding the root cause, to fixing it, they did everything via Komodor. Now, I'm not trying to argue that all of our customers' issues can be resolved in 3 or 4 clicks. We're all by far multi-billionaires by now if this was the case. But I can definitely say that a lot of issues can be resolved in a few clicks instead of sometimes hours of troubleshooting and investigating and involving multiple people. So I think this gives an intuition regarding the understanding part, how we surface the interesting information in the right context of everything that changed in your system. And also, to the manage part, how we offer actions that you can take once you figure out what are the suspect root causes in order to actually solve the issue. So this is one example out of many, but I hope it sheds some light.
Yeah, and actually, I think that's a great and powerful example. Another thing that would be interesting to know, how does your Komodor tool is different from those available in the market that are already helping DevOps and software engineers to understand what is going on within their Kubernetes applications. So what differentiates you from the available solutions on the market?
Sure. So first of all of our users, without any exception, have some monitoring tools in place, Grafana, Prometheus, Datadog, New Relic, AppDynamic, you name it. They probably have some logging solution in place, Splunk, Sumo Logic, Logs.io, ELK, and they probably have some incident response tool in place, PagerDuty, VictorOps, OpsGenie. I really hope that I did free commercial for all of those companies and they will return the favor someday. No, kidding. So obviously all of our customers have those tools in place, right? Even though they have those tools in place, and assuming they're using Kubernetes, because we only work with companies that are using Kubernetes, what we learned is that the first go-to tool when they have an alert or when they have an issue is Slack or Teams. And what they do with those tools is basically asking in English, hey, did anyone do something in production or did anyone change something? And they're hoping to get a nugget. They're hoping to get, a concrete response from one of their teammates saying, oh yeah, I did it. It's probably my fault. I will revert. And it's so interesting to see, even though how they pay so much money and how they use very, elaborative and comprehensive tools like Grafana, Prometheus, Datadog, ELK, etc. They still go to Slack and they're asking someone if they can help them or if they know if someone changed something, because it's so complex and because it's so hard to do those inspections by yourself when you don't have the right context of how to do those things in Kubernetes. So basically what we do, we don't try to compete with those tools. We work together with them. So we have integrations with all of the monitoring tools, with the logging tools, with the incident response platforms. And what we do, we constantly collect those events together with the events we collect from the code repository, from the Kubernetes, and from the configuration systems. And then we digest this information together so we can actually provide a coherent story of changes, root causes, and symptoms. So instead of just getting an alert from Datadog, I can show in a single timeline an alert from Datadog, but also an exception from Senti that happened right before that, and a few code changes that happened right before the exception, and also maybe some snapshot of what happened last time this specific alert hit and how the team fixed it using a specific job in Jenkins, for example. So what I'm trying to do is we're trying to take all of those different tools and reduce the complexity needed basically to be a master in all of those different tools and to be an expert in all of those different tools. So the only tool you actually need to know in most of the cases in order to troubleshoot end-to-end issues is Komodor. So I hope it provided you some context of how we see the nature with those different integrations. And if you can even see in my background, we're proud to have logos of Sentry, Datadog, Slack, and so on, because we have a very deep integrations with those tools.
Well, that is something that is specifically interesting to me when we actually, instead of allocating specialists in each and every technology to troubleshoot this or that issue, we can use one tool that actually can go across multiple technologies. And I believe that is more efficient allocation of human resources and financial resources. Yeah, well, the next question that I'm interested is about the change intelligence. I saw that on your website. I saw that you've been talking about that concept. If you could elaborate a little bit more for our listeners to understand what is behind that concept and whether you use artificial intelligence to power that concept.
Sure. So we basically tried really hard to find a term which is not using AI in order to describe what we do. So, and there is a few reasons for that. So first of all, change intelligence basically means that we acknowledge that in today modern systems, distributed systems that compose of thousands of different subcomponents, we acknowledge that changes is the key of really understanding what's going on in the system. Just like 5 years ago, a decent organization, like a good modern organization, used to do a deploy once a quarter, right? Once a month. Like the top-notch organization maybe had a weekly deploy, right? Maybe. Today, we're talking about thousands of changes that are happening in every organization, even in a small startup like us. We're making hundreds of changes every day. So basically what we realize is that if you really want to help, given an issue, given an incident, given something is off on your system, the first thing that is today missing and the first thing you should pay attention to is how to take the changes that happen in all of those different tools, like code changes, configuration changes, Kubernetes changes, etc., and to do some analysis on top of them. So basically, change intelligence means you have an issue, let Komodor collect the changes that happen, try to correlate them, and I can explain how we do the correlation, try to digest them, and then to give you, the developer, like the DevOps or the SRE, a coherent story of what happened, so you can conveniently choose with your intuition and experience what is the most likely root cause out of this small subset that we found, and fix it or revert it, etc. So when we talk about change intelligence, we're obviously using some data-driven models. We're obviously using some different ways to correlate events. Primarily, we do that with a very vast knowledge and experience with how Kubernetes works internally and how Kubernetes works together with other tools like Jenkins, Argo CD, Datadog, Sentry, etc. So, for example, the easiest example is we know how to take a code that a developer did on their computer, and basically we know how to track this commit or PR from GitHub to a specific Kubernetes deploy that just happened, to a broader picture of everything that happened around that service, and also to collect different configuration changes that happened maybe recently, and show you everything in a single timeline. And we know that they relate to each other because all of them affected in the end on the same service object in Kubernetes or pod object in Kubernetes. So we know how to take pieces of information from different tools, tie them together, and tell a coherent story about each one of the smaller components in your system, whether there are pods, services, teams, groups, whatever. In terms of how it's different from AI ops, so obviously, like any category, AI ops in particular, it doesn't mean one thing, right? It basically is something that was a bit trendy to talk about like 7 or like 8 years ago, when great companies like Movesoft and Big Panda emerged, and they try to say, hey, like, the complexity of alerts, specifically alerts, is so high for the IT and no guys that a person cannot scan 1,000 alerts every day, right? So if you're a NOC or if you're an IT person working for, huge enterprise, and you're getting 1,000 alerts per day, probably a human being can't scan all of those things. You probably need some help, right? So AIOps originally referred to, hey, let's use AI or regular expression or whatever technique there is to reduce the load of a lot of alerts, like the noise of alerts, so we can correlate 1,000 alerts maybe to only 10 possible main alerts, right? And it has a lot of value and a lot of advantage. And I think they're doing great. And I think they're providing a lot of value. What we do is basically we try to provide a different value for different person in the organization using different product, right? So what we do, we try to take the actual things that change in the system, code, configuration, infrastructure changes, etc., and we try to collect them into a more coherent story and then to correlate it with alerts. So it's a bit of a different problem we're trying to solve. We are not mainly relying on AI. We're mainly relying on our deep understanding of Kubernetes and how the internal works in Kubernetes, and from years of experience of how troubleshooting looks like in Kubernetes. But we are not afraid from the world AI. So we definitely have some data-driven models. We're definitely using AI in different aspects in the products, but this is not the main thing that leads our value creation for the users. It's basically our deep expertise and understanding of Kubernetes itself.
Well, yeah, I would say that is a significant change. And since Ben, you're working on non-trivial tasks, right, that you are helping to solve to the industry, you must be working with people that help you solve these problems and have specific skill set and specific experiences. If you could share what type of people you're looking to bring into your team. I know that you are around 25 in your team. So what kind of people you're looking to bring in order to foster that innovation culture?
Yeah, so the short answer is people who are by far smarter than me. Who can really do those things. I can talk about those things. I can try to understand those things, but there are some people who can actually, build those things and fix those things, right? So the people we're usually looking for is a very builder type personality, people who are not afraid from challenges, people who are not afraid of getting out of their comfort zone and trying to solve issues that you don't have answers in Stack Overflow or Carrera already. We contributed to Kubernetes API, etc., because we found very rare race conditions that we needed to handle and fix. That even the Kubernetes open source community still didn't fix. So we definitely look at people that are keen in deep technology, are a fan of DevOps movement and Kubernetes, and really want to change how people are troubleshooting. I think it's one of the most interesting missions to do. And I definitely look for more people that share the same, drives, share the same vision, wants to improve developers and DevOps lives. And if you are one of them, please let me know and we will know how to bring you into the team.
Well, Ben, I think you're being humble about your skills and about your knowledge. Nevertheless, it's a great note to end on, right? As I believe you have a very noble mission in the world of technology. So thank you so much for your time and for your insights about the tool and the platform that you are building. Thank you so much. It's been a great pleasure to have you on the show.
Thank you so much. It was really fun.
Thank you.